Good afternoon. Welcome to our Python training session. I'm very happy that you have joined us to learn about Python. Please feel free to communicate with us throughout the presentation. What you do is just simply type your questions or comments in the chat message. My name is Desali Haptizgi. I'm a faculty member in the Department of Mathematics. I'm also the director of the Consulting Center. With me, there are three of my students, Maria, Judy, and Zahra. They're part of the Consulting Center. I'm sure I'm going to give you just a very short summary review of the Consulting Center. The Consulting Center is housed in the Department of Mathematics. It is part of the centers of our College of Science and Health. The center provides expert statistical assistance in all sorts of quantitative research. Where we help is we help DePaul faculty, DePaul staff, and then DePaul students. In addition to that, also we help outside clients like academic agencies, government agencies, and profit organizations. And then one of the goals of the consulting center is to help our students. Our students basically just they learn about real world consulting, and also we expose our students to all aspects of research, like it could be like data collection, modeling, evaluating results, and report writing. And also we give free training in SPSS, R, Python, um, and then this one can help our students and other students to learn about those different statistical software. So today we are going to go over the Python one. Just to give you an idea, Python and R, they are open source programming languages. R is very useful for statistical computation. It's useful for performing complex statistical calculations on data, as well as for data visualization. Actually, if you want to create a high-level graph, R is the best. Due to its open source nature, R and Python, they have massive community, and both of them, they create a large number of packages or libraries that make Python and R capable of performing all data science tasks. So Python is famous for web development, software development, and data science. It has a wide variety of libraries that can allow us to do a lot of different tasks like data transformation, data filtering, and data wrangling, and machine learning and predictive analysis. So today, what we're gonna do, just we are going to overview of that, just kind of like intro level. Um, but next time, if you are interested, also we can go over the advanced level of Python. So when you go to next slide, this is just, yeah, you can see here the difference between Python and R and SAS. Both of them, they're easy to learn. As I said, they are open sources. They have massive SAS community and Python community. When you look at the flexibility, they're easy to learn, both Python and R. Um, when you're looking about statistical packages, R has some upper hand compared to Python. But when you look for the time efficiency and then web development, Python has upper hands. SAS is also a good one, but the issue with that one is it's expensive. So what I will do is now, through our TS are going to do the presentation. So Maria should just going to give you the intro, and then from there we're going to go to Zahara and then to Judy. So it's yours.
Welcome. My name is Mariah Hill, and I am a master's candidate at DePaul in applied statistics. And so today we are going to touch on a few topics. We'll start with getting started with Python, the beginning uses of Python, the Python libraries, variables, data types, sequence types, operators, basic calculation, module, data visualization, and lastly, data analysis. Switch the screen. All right, so we'll start with section 1. What is Python? So Python is a widely used, high-level programming language for general purpose programming. It has a large and comprehensive standard library, and Python code allows you to run on various systems as well. You can go ahead to the next slide. Thank you. So here is how you download Python. You have the link to the slides. So if you want to click on this link here, the www.python.org, you'll see a list of operating systems. So you have Mac, source release, and Windows. From there, you can pick whatever system for your device, and it will show you the list of available versions. The latest version is Python 2.718 and then Python 3.9.2. So here are the various types of editors in Python. You have the Anaconda Navigator, which is really easy to install packages, which we'll see momentarily. We also have Spider, Eclipse, PyCharm, VIM, and then if you want to see a list of others, you can go to this link as well, and also for additional details. All right, section 2. So once you have Python installed on your device, you can then install Anaconda. And here's are the various steps to install Anaconda. You first want to visit this link here, anaconda.com/downloads, and you will have all of these links available to you in the slide deck. Once you get to that site, you'll select the Windows, you'll download the installer, and then you want to open and run it. From there, you can open the Anaconda prompt and run it, run some Python code. Right. So now that you have Anaconda installed, how do we install packages? So like I said before, Anaconda Navigator is one of the easier editors to install packages. So you want to go to your environment, type in the package that you would like to install, and from there, you'll click, it will open up, and now it'll be into your environment. If you don't use Anaconda Navigator, you can also use the pip operator as you see below. We have it for OS X, Windows, and other devices. These are the different pip operators. You'll type this into your console with the package that you would like to install, and then you'll run that code. So notebooks. So this is one of the key things in Python. How do you run your code? How do you open notebooks? Jupyter Notebooks are one of the powerful ways to write and iterate on your Python code for data analysis. So this allows you to run and write certain codes. You can run them one at a time. You can run all the codes together. And it also allows you to edit and rerun code if you want to go back and change it as well. Now, to launch Jupyter Notebook, you must open your terminal and then navigate to your directory where you will save your notebook. From there, you'll type in the command Jupyter Notebook. It will go to a local server, and then you'll now be in your Jupyter Notebook interface. All right. So once you get into your Jupyter Notebooks interface, these are the ways you can create a notebook, upload a notebook, or access a previous notebook. So to create a new notebook, you'll see these two tabs here. It says new. This will appear in the upper left hand of your notebook. It'll say upload and new. New, once you click that, it will appear a drop down. From there, you click on Python 2 and your a new notebook will be created. If you want to upload a document, you can also click the upload, which will be right next to the new drop down. From there, you'll select the document on your PC or your drive to upload it into your terminal. If you want to select a previous notebook that you already have running, you'll see from the image in the lower right-hand corner of the screen, this image is like all of your notebooks that you have available. The green icon shows notebooks that are currently running. If they are not running, you'll also have gray icons next to it to show that it is not running. All right, so these are also the menus at the top of the notebook. You have eight menu tabs: File, Edit, View, Insert. You also may see Sell or Run depending on your system. And then Kernel, Widgets. This also may say System Settings or something of that nature. And then Help. It will always be those 8. File, this allows you to open, save, and access notebooks that are on your PC or in your terminal. Edit allows you to copy, paste, move, and delete cells. A cell is where you type in your code. So once you open your notebook, you have a cell that appears. This is where you are allowed to like type in the code, and then you'll run the code from the cells. So that allows you to move those around, edit it, copy it, and paste in the cells. View allows you to customize your screen by hiding the sidebars, expanding the code, and allows you to minimize or expand your workspace. Then this cell or run, depending on your system, this allows you to run the selected cells that you have or also run all the code in your workspace. Then we'll skip over to kernel. Your kernel allows you to restart or shut down your kernel. So a kernel is a computational engine that executes the code in your workspace. So this is the engine that does all the running, does all of the executing of the code. Lastly, the last widget on the end is help. Help shows FAQs, reference articles. It also has information about Jupyter. So if you're left and you're unsure about something, 9 times out of 10 is in the help tab. All right, now I will go ahead and pass it over to Zahar that will go into section number 3.
Sarah, you're on mute.
Hello, and my name is Zara Bakari, and I'm also a master student in applied statistics. So I will be presenting Python libraries section. So what are Python libraries? In every programming language, they have a default and code written that help you, facilitate when you are writing your own code. So you don't have to start from scratch. So Python library is a collection of predefined combined code that you can use over and over and help you reduce time required and also eliminate the need for writing code from scratch. So there are up to now 137,000 Python libraries. So we're just gonna discuss the most common one. Next slide, please. So the most common one on library are Panda, NumPy, and Matplotlib. So I will discuss briefly each one what they does, but later on Judy will walk you through with different examples. So Panda, and it helps you load data, read file, and you can also rename function, and you can also get the shape and column of the data and basic plotting and handling missing value. Next slide. Okay, and NumPy is one of the fundamental packets for Python. It can be used to perform a number of mathematical operations on array, such as trigonometric, statistical, and algebra. And the most interesting one is Matplotlib. It's used for data visualization, and it consists of several different types of plots, such as line plot, scatter plot, histogram, and three-dimensional plot. As you can see the picture on the blue, the first one is line plot, and the second one is the scatter plot, histogram, and 3D plot. Next section, please. Okay, now we're going to talk about Python variable, what they are and what they do. So just like algebra class, if you recall, you have a variable you assign to a value and use that variable to compute some mathematical operation. Same thing here for Python. So you declare a variable and assign to value, and then you can use later on. So it's so simple and easy. And I can walk you through in Python editor to show you how you can compute. Okay, let's share. Okay. Okay, this is Python editor, and this is called shell. And this is a markdown that you can write your own comment, whatever. So here I declare a variable named x and assign to variable 5. Then I go to run the code. So this is I already assigned. So if I want to print the content of x, I will use print x and I run it. So I have 5. Variable x have value 5. So we go to the slide, please.
No, just a moment. When you look at this one, yeah, thank you, Zahara. When you look at this one, it is one of the editors. Maria was talking about different editors. One of them is Jupyter. Now Zahara she is using a Jupyter editor, and so she's creating a variable. Everything in Python is an object, like a vector is an object, a data frame is an object, a factor is an object. Everything is an object. So that's the way she is assigning, and then she's executing it. So she's using the Jupyter editor, but there are many editors.
And this is the notebook where I type my own code and I name it workshop. So you can have as many as notebook you wanted for each project you're working on. It's so simple, user-friendly, nothing crazy. Everybody can go in and write their own code. Could you go to the slides so I can? Oh, I have to unshare. Okay. 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 So next slide. Okay. So in Python, there is a rule when you name in a variable. So the rule is, the variable have to start from a letter or underscore, and it can contain anything and from alphanumeric character or underscore from A to Z, 0 to 9, and underscore, but it cannot begin number. Otherwise, Python and the editor will return an error. And also variable name are case sensitive. For example, age, all and lowercase, and age and a cap and age all cap. These all three mean different variable. So don't get confused when you're declaring a variable. So it's case sensitive and be careful. So I can share my screen to show more about the variable. Okay. So here we have age, and so this is age I assigned to the value of 22 and 8 underscore 1, 22, and 1 underscore 8, 22. So I'm gonna run this chunk of code. When I run it, Python, it gives me an error. Okay, let's see. Okay, the first one run fine. I can print 8. It run fine. But if I want to print the 1, if I'm violating the rule of variable naming, I put here 1 underscore 8. So this is invalid token because it cannot begin with number. This is what I mean Python naming and variable rule naming. Okay. Okay. So let me unshare. Okay, could you go to the other slide, please? Okay, there are different data type in Python, and the most important one are numeric, Boolean, and string. So numeric means just a whole number, positive or negative. Boolean is true or false. It's an expression. So when you have two expressions, Python evaluate the two expression and then return true or false based on the comparison operator you are comparing between the two variables. And string is the sequence of character or text value. We will discuss each one and show you example in the Python editor. Could we go to the next slide? Okay, so numeric, it can be an integer, float, or other complex number. And you don't need to declare in Python because Python would recognize automatically what you type in. That's the good thing about it. And Python, as Mr. DeSales said, is the object-oriented language. And it's the method that you can bundle related property and behavior into individual objects. For example, if I want to declare two different variables, I can do that in one single line instead of saying A equal to 5 and B equal to 2.5. And I can show you that in the editor. Let me share my screen. Okay. Here, I can do either way, this way or this way. The result will be the same. So A will be assigned to the value of 5 and B 2.5. And then later on, I can create another variable C that have the product of A and B. When I print C, it have 12.5. And this is another little bit complex mathematical operation you can perform in Python. For example, variable X I'm assigned to 2 to the power of 4 minus 8 module 3. I can do this simple, run it, and the value is 14. So now we discuss about Boolean type data in Python. So Boolean type of data is like, it can return either false or true. So it's a comparison and it's comparing two value Python, and you have to use this operator equal to, not equal to, less than, greater than, less than, equal to, or greater than or equal to. And so what Python does is it's gonna compare the expression of the left side and then the expression of 8 to the right side, and then give you if true or false based on the value you are plugging each expression. Let me share my screen. Okay. Here I assign x equal to. So I wanna check if x equal to y and see what will be the result. First, I have to execute an x and y variable and then print it because on Python gonna compare the value of x and y. Are they equal to? No, then you're gonna return false. Again, here is x not equal to y. It's true because x is not equal to y.
Are you sharing with us your editor? We see only the PowerPoint.
Oh, really? I shared the editor. Oh, hold on. Oh, I'm sorry.
There you go. Thank you.
You see now?
Yes, thank you.
Oh, okay. I don't know what this. So another evaluation is x less than y. That is the true statement, and x greater than y. So it's based on these two values, x and y, 5 and 8. And then is x less than or equal to y? That will be true. And is x greater than or equal to y? That will be false. So on another, So can you go back to the PowerPoint, student? I don't know on my connection somehow. Can you guys see me?
Yes.
Yes. And you see my screen, right?
Mm-hmm.
Okay. Okay, now we talk about string. String is another data type in Python, and is included within a quotation. I mean, it could be single quote, it could be double quote, it could be triple quote. Either one will give you the same result. And for example, if I have to print, a simple string, greeting, for example, hello, welcome to Python workshop. I run that and it will be printed, and I include double quote. Okay, now I'm going to talk about Python sequential data type, and there are three. There's some. The most common one is tuple, list, and string. So all these three share the same functionality and the same syntax. There is only one key difference. And string and tuple, you cannot modify, and it's called immutable. Unless you can modify after you declare and you create, that object, you can change it. So what I mean in tuple is here. So the way you create tuple is like, you can, this, and what do you call it? It's not, yeah, this bracket is not mandatory, but it's helpful. It can organize your tuple. It's not a mandatory. The result will be the same without it. So if I create this tuple, have 1, 2, 3, and it's a sequence of number, and I print it, it will have 1, 2, 3. And it can also have a mix of different type of, variable. It can be number, it can be string. Here it's a number, string, another number, decimal point. And when I run it, right. So I have a list of, I have a tuple that have number and string. So this is what I mean. The tuple, you cannot modify its value once you create it. For example, if I want to modify an index number 1, because Python on index work from 0, 1, 2, and so on. So if I want to modify index number 1, which is hello, and replace to hi, I cannot do that. If I run here, I'm gonna have an error. Tuple object does not support item assignment. So that is what I mean immutable. On the other hand, list is one of the most frequently used in Python data type, and it's mutable, and it can be created the way I say, single quote, double quote, or triple quote. But for programmer, they prefer either single or double quote. So triple quote is not common, but still, it's something you can use it. And also, list can be a sequence of data, and it can be also a mix of, different data types. So here I have a sequence of number. This is how I create, and you have to include within an bracket, square bracket. So here I created a list that have 0 through 9 number. Here and pet, I'm creating a list of pet name. It's a sequence of pet name. I run it and I print it. So this is the beauty about list. I can change the value anytime I want it once I create it. And before that, let me show you a mix of different data type. It have a number, string, and another list. So I have number, string, and another list that have a number and a string. So if I decide to show this list from cat to snake, I can do that. So index number 1 of pet, I can run it. So I changed from original on list that had cat to snake. So cat is no more here. So list is very versatile. You can change anytime you want it once you declare it.
Can I add a little here, Zahra? Thing? Yeah. So as Zahra said, list and then tuple, they are data structures of one dimension. For a tuple, like for example, days, they are fixed, so you want to keep them. Monday, Tuesday, Wednesday, Thursday, and Friday. So if you want save the, if we want to save them as a vector format or list, so you can use like a tuple because you can change them. But if you have a plan to change the value or the item of that vector, you can use a list. But if they don't change, use a tuple. Like for days, months, you can use a tuple. But for the other, like it could be age or other variable, you can use a list. Thank you.
Okay. The next sequential data type is string, and string must be enclosed in quotation, either single, double, or triple. And here I have an example. I created a variable named st, and I store hello world with single quote. Same thing here, double quote. So let's run it and print it. Gonna print hello world. The second one that have a double quote, the same thing, gonna print same answer. And the third one, it have a triple quote here. When I run it, gonna print same answer. So it's up to you which one you wanna get adapted to. But for me, I just like the double quote. I don't know. So now I'm gonna pass to you on. If you don't have a question, if you have a question, please feel free to ask right now about what I cover. Okay, then I'm gonna pass to Judy.
Okay, thank you, Zara. So let's get into some actual uses of Python, do some demoing. So what you can do with Python in a really basic level is use it as a calculator. And there are different modules or libraries that you can use, or you can use the built-in arithmetic operators. So Zara mentioned some of these earlier, but here's a detailed list of all of them. And then, so basically, we can also use the modules that are in the library to also do basic calculations or whatnot, data analysis, data visualization, whatever you're looking for. But this is the most basic thing. So for example, there is the statistics module, so let's do some demoing. So yeah, everybody, if you need to see the code that we're gonna do, it's in the chat. So just follow along down here, starting at import math. So what we'll do first is show you how to actually import a module. So it's basically just the function import, and then you put the name of the module. We're going to use the module math right now as a demonstration. And then if you want to see all of the different functions in for any type of module or library, you just use the function directory and you put it inside the parentheses, and then it's going to list all of the functions within that module. So as you can see, we have all of these math functions. So we'll just do a basic math function and see, oh, great, we get one. Excellent. So it is working. And then if you want more information about any modules that you're using in Python, you can always use the help function. And then it will output basically information about the module. And then you can also get more information about the syntax of the different functions in the module when you click on the link. So also, you can do some basic statistics functions in Python. So typically when you import a module, you'll import it as something. So some kind of abbreviation just to shorten it. And you'll see why that is convenient. So we'll import the module statistics as stats. And then we'll create a one-dimensional data vector, or in Python, usually it's called an array. And then from that, we can use different functions in the statistics module. So first, in the module, you have to write here your abbreviation for the statistics module. So we put stats, period, and then we put the function mean. And then we put data inside the bracket or the parentheses to find the different outputs that we're looking for. So we can also look for the standard deviation. And if we go back here, you can see all the different, these are just a few of them. There's a lot more if you look on the website, but these are some common summary statistics that you would be interested in. And if you had just one line, one set of data points, you could use Python very easily. So yeah, so, and then, so Python is actually built kind of on NumPy, which is called numerical Python. And NumPy is the building blocks for the data structures of Pandas. And Pandas is basically what allows you, and Pandas is a library. It allows you to work with data frames in Python, because unlike R, data frames are not built in to Python. So you have to install a specific module to do that. NumPy is the most basic. So NumPy works with arrays. And an array is just like a vector and a 1D set of objects or numbers. And but what's great about NumPy is that it allows you to manipulate these numbers. So and then but it's just a introductory actually for using Pandas. So it's kind of like a building block for Pandas, which is the data frame structure is what you're really looking to work with. So here's some common NumPy functions. So you can load data using NumPy, but most commonly people use Pandas. So let's do some demoing. So here, oh, oops. Sorry, so we have to import, we have to activate the NumPy library first, because we haven't done that first. So before you use the NumPy module, we have to activate the library. So we import NumPy as NP, and then we can, there's a function where you can create a random data array. So when you look at this array I've created, which we can call by typing data in here, you can see that there are 5 rows and 3 columns. And what's great about NumPy is that it allows you to subsection the data as well. So, but you have to remember that 0 is 1, or the starting point in Python. So if we type in data 4, 1, we're trying to call the object in the 5th row. So it starts at 0. So 0, 1, 2, 3, 4. So the 5th row. So, and then the second column, because it's 0, 1. Oops. And then press 1. And then so yeah, we get this number right here. So that's how you subsection. But more importantly, we're going to use NumPy to build on Pandas, which is what most people use for data wrangling, data preparation, to move on their data for more data analysis. So here are some common Pandas functions, and they're a little bit similar to the NumPy functions, but in Pandas we can work with data frames. So you can have multiple columns, multiple rows. So let's see. And then there's also a couple of statistic functions too here too that we've listed, but let's just do some demoing. And so of course, the first thing to do when we start with a new module that we haven't activated yet is we have to import it, and we're going to import pandas as PD. And then what we're going to do is pandas allows you to import CSV files, TXT files, all different types of files. So we're going to import a file, and just also, like, sometimes people get confused because they're not sure where their working directory is or like how to find the file on their computer. So if you do, just type this in, and then it'll tell you exactly where your data is. And this is my computer. So yeah, so.
Judy, can I comment on this one?
Yeah, go ahead.
Okay, thank you. So thanks so much. So when you see when Judy create for the Panda, she put PD. So usually programmers, what they do is when they create alias or like a temporary name, because it's kind of easier to refer it, to have, to have the second way to refer it. That's why actually she mentioned that one. The other things also what I want to mention is most of the programming languages like C, C++, Java, even R or SAS, they use brackets or braces, to define a block of a code. But in Python, just we use indentation to do that. So when you use idle or other editor, sometimes you may have to indent it. But when you use the JBeater, because you are using different cells, sometimes you don't have to do that. That's the advantage of using the JBeater editor. Thank you.
Okay, thank you for clarifying. Okay, so if everyone can see, now we're using pandas to import our data set. Oh, sorry about that. So it's important. If you want to see your data, you can just use the head function. So you put your data frame name, which ours is named data, period head, and then it'll give you the first 5 observations for your data set. So we can see some of the names of our variables and some of the values in there. So we have a mix of different types of variables. And then also when you're looking at a data frame, you can also use the shape function to see how many observations and then how many variables you have. This is just like some basic subsetting that you can do in Pandas too. If you want to subset your data, use the iloc function, and basically, so the first part, 10 to 12, you're calling which rows you want, and then you can, and then you put the comma, and then if you just leave it with the colons, then it'll bring all of the variables. But if you specify which variables you want, then you'll only see a few. So you just use this function, and then so that's just like a very basic way to do it. And then if you wanted to do some, really, you wanted to find like the correlation of your data set, what you could do is you could use this function, and it will tell you the correlation. And then, but then I know it's a little confusing because we're not writing PD at the beginning of the code, but it's, I know, and I'm just pointing this out because here we just write data, data, data. But if you remember, data is actually PD.read. So these are all pandas functions, but it doesn't seem like it is first because you're just like, oh, it just says the data, but actually data means PD read abalone.csv. So that's just something to keep in mind because sometimes you can get confused, like, where did I put the PD function? I know I do. So anyways, so those are just a few statistical functions that we can do in, or just a few things that you can do with pandas. And it's used a lot for data wrangling too. So you can also mutate your data too. If you wanted to like create a new variable, you can like divide it by a certain number, or yeah. So it's just some basic stuff, but obviously it gets a lot more complex. And then so now we'll just go over a few ways that you can use data visualization in Python. So the most popular libraries are Matplotlib, Seaborn, ggplot, and Plotty is somewhat popular too. But these are the most used in for Python. And actually, Matplotlib is the most used package or module or library for creating graphics in Python, and it is pretty easy to use when you want to create a basic graph or plot, but it's a type of thing where you have to build your graph one feature on top of another. So if you want your axes to look a certain way, you can edit it, but you'll have to write code to make sure that that's done. So it can be a little bit more complicated, and and a lot more code is needed, but you can create the most customized graphs in Matplotlib. And then, so here are some easy functions for creating, the basic graphs: bar plot, box plot, histogram, pie, graph, scatter plot. And then here are some ways where you can add customizations to your graph. There's a lot more, but these are just some basic ones. So if we, so let's try to do some basic graphs using Matplotlib. So we have to import the Matplotlib module. So this is like the full module name, and then you just press run. And then, so suppose that I just want to look at, so I create a new data set. Oh, oops, sorry. Sometimes that happens. So I create a new data set. It's just the height variable of our abalone data set. And then and then I can just use the basic plot function to plot it. And then you can see it defaults to a line graph. So this function defaults to a line graph. So just keep that in mind. So it looks kind of crazy, but if we wanted to get some information on that, we could also change the kind, because it's to be a histogram. And then so all I did was I just put you just move this over here, and then you just change the kind to histogram. But there's actually a couple different ways to create a histogram. This is just one way. And then since we're using Matplotlib, we can add customizations to our plot. So how do we do that? So it's pretty easy. So if you wanted to add a title, you just type in the code right after it, and then run it together. And then here, boom, you have the title right there. And there's a lot of different things that you can do. So say, for example, we wanted to add a legend, and we want to change the limits to shorten this graph because there's a lot of white space. And we want to add a title, and then we also want to add a label. These are all things you can do with Matplotlib very easily. It just takes a little bit of typing. And there you go. But so it requires a lot more. I mean, this isn't too much, but once you start creating customized plots and graphs, it requires a lot more coding and knowledge, somewhat more knowledge. So there's actually another package that's really popularly used not as much, but it's called Seaborn, which is based on Matplotlib, but it's a lot more easier to use. There's a lot less coding, and it works well with Pandas data frame. There's a lot of functions, but here are some main 3 functions that they came out with in their most recent update of the Seaborn module. So these are like kind of new and really cool new functions. But so let's just get into it. So we can import, or we activate the Seaborn module as SNS. So you can write anything there, but it's just, that's what most people call it. And then there's actually some data sets that are already loaded into Seaborn. So just for fun, let's check that out, and then we can use one of those data sets for our example. So if we use this function here, we can get all of the data sets that are already loaded inside Seaborn. And then let's use the MPG data set because, you know, I like cars. And then, so with this function, we load the SNS data set, MPG, and then we name it MPG. So let's just check that data set out using the head function that we mentioned earlier, which will show the first 5 observations. So bam, we can see all the different variables, and we see we have somewhat of a mix of categorical and numeric variables. And then, so here we can see that the main, so I don't know if I just explained this earlier, but these are the main functions. So rel plot, displot, and cat plot. So those are the main functions in Seaborn that we're going to talk about today. A lot more, but these are easy to use because from these functions, you can create a lot of different types of graphics. So we're going to start with the rel plot, which is supposed to be like a relational plot. So it's supposed to be like you're relating 2 different things. So it's like a scatter plot or a line plot. And the default is scatter. So when we type it in here, I just wrote X to be cylinders and then Y to be the acceleration. And then you can see that we get like a scatter plot, but because it's like categorical data, it looks kind of like that. But if we try to change, we were like, oh, it shouldn't be a scatter plot, it should be a line plot. Then we can change the kind right here. So it's the same code, just like the last, we just add this at the end to change the type of graph that we're creating. So here now we have a line graph. And then next, if we wanted to look at the distribution plots, we can plot a histogram or a kernel density plot. So same thing, it's pretty easy. The default is a histogram. So it'll default as a histogram, but if you want a KDE plot, then, oh dear, sorry, sometimes that happens. You just change the kind and it will create the plot for you here. So it's pretty easy to change them. And then lastly, we'll just look at the categorical plots. So here's just a box plot. And if you want to add customization in any of these Seaborn plots, you can actually use matlib plot. So what we kind of went over earlier, the functions for adding like a title or changing the axes or adding a legend, you can do that for all of these Seaborn plots too. So we plotted that box plot, but if we wanted to add a title, you just add the matplotlib function right after it. You run it together, and there you go. You got the plot with the title, and then you can add whatever other customizations that you want. And yeah, so that is basically it. for the introductory Python tutorial workshop. So hope you guys liked it. I hope if this was your first time becoming familiar with Python, it helped you a little bit or a lot. And also all of this material is available online. We put the links in the chat. If you guys have any questions, just feel free to let us know.
Yeah, thank you, Judy. Thank you, Zahara. Thank you, Maria.